Terminology here. Terminology. Terminal. Ha ha ha. I don't know. Just kind of struck me. All right. Terminal side is the side of an angle that rotates about the vertex or center, I would say, or origin. Or you could look at it as the ending side of the angle. And I'll show you in a picture down below. If you're not quite sure what that means, you'll see it in a second. Standard position is an angle with its starting or stationary side on the positive x-axis. It rotates counterclockwise. Okay, let's talk about what that means here doing these sample problems. Draw an angle with the given measure in standard position. So that means we're starting right here with our standard position. And we're going to rotate it, which direction? Counterclockwise, 135 degrees, which would be right here, 90 plus 45. So this way, that's 135 degrees. Easy enough. Okay, then it says, okay, do 640. Well, I know that there's going to be at least one complete rotation in there, right? 360 degrees. So again, I'm starting here, and I'm going to go around at least once, and then let's see what's left over after we do that. 640 minus 360 is 280 degrees. So that means I'm going to take this angle, I'm going to go completely around once, that's 360, and then I'm going to keep going 280, which, if you think about it, this down here is 270 degrees, correct? And then I got to go 10 degrees about further than that, so it's going to end about here. A complete rotation, and then another 280 degrees. Cool? Easy enough. All right, what's different about this one than this one? It's negative, which means we don't go counterclockwise, we do what? Yes, go clockwise. Okay, go clockwise from the x-axis. So here we go, we're starting here, and we're going to go clockwise 105. Here's 90. It'd be about 15 past that, so you just kind of guesstimate. It doesn't have to be exact. This would be, actually, let's write negative 105 to be exact. It would be negative 105. How else might that be written to give you the same angle? The other way, does anybody know what that amount would be? 255, correct. If you went this way, it would be 255 degrees. Okay? All right. Another definition, coterminal. Coterminal are angles with the same terminal, which is the ending side. Angles with the same terminal side. Semicolon. There's more. They are plus or minus multiples of 360. And I'll show you what I mean here in a second. Just write this down. Or, in radians, how much is 360? 2 pi. Remember, one complete rotation around the unit circle was 2 pi radians. Different units of measure is all. To the original angle. Okay, so it says find one positive angle and one negative angle that are coterminal with the angle given. So what you have to do is pretty much you should add 360 and subtract 360. So this is at negative 215. If I add 360, I'm going to get 145 degrees, and that is one coterminal angle to the one they gave me. If I need to draw a picture, you can draw a picture to visualize what that means. It basically just means if you went negative from this direction, negative 215, you'd over here, right? And then this 145 is just that direction. It ends in the same spot, coterminal. Make sense? Okay, and then if you subtract 360, you'd get negative 575. That one would also share that terminal side. Now this one's a little funky because it's already starting bigger than 360, but that's okay. We can still subtract 360 and get an angle that would be coterminal, which is 210 degrees. But instead of adding 360 and getting a huge angle, if we subtract another 360, I'll show you what we get and then I'll explain it to you in pictures. You get negative 150. So these two angles would actually be coterminal to 570. I can show you a picture if necessary. 570 would be 360 and what? Just hold on a second and I'll show you what I mean. 360 plus what would give you 570? 210, right? So that means if I'm starting here and I go around one whole time and then I go around 210, here's my original angle, 570 degrees, correct? Okay. When I subtracted 360, I got another angle that would also go around 210 degrees. So that's another angle that shares that terminal side. Make sense? Rather than going really big and doing a bunch of circles, I just went and decided, well, maybe I can find this measure here, which would just be a smaller angle. And that would end up being negative 150. So that's where I did it that way. Basically, all you're looking for is angles that share that same terminal side as the original one. Does that make sense? Could you add 360 and give me an answer that's huge like that? Yeah, you could. Okay? Yeah. Ben? Because I just went 210, here's my 210 angle, right? And I have to have an angle that ends here. So I did 360 minus 210, basically, which is 150, but since I'm going clockwise, it has to be negative instead of counterclockwise. So it's negative 100, oh, it's not, I see what you're saying. Oh, I think I put it in the wrong spot. Did I put it in the wrong spot? I did put it in the wrong spot to start. So ignore that drawing. Let's do it over. Here's 360. Here's 210. That should be 210. I just put it in the wrong spot to start. Make sense? Apologize. Thank you for pointing that out. Then here's my 210 angle. And here's my negative 150 angle. Better? Thank you. Yeah. Yes?
So on test, if instead of subtracting
It would still be okay. Because they can be multiples of 360. So, all right, I don't want to do this one because sometimes you'll be doing problems that are given to you in radian measure. So let's say we start with this angle, 5 pi over 4. And we have to add 360. That's okay. What's 360 in radians? 2 pi. So you would just do 5 pi over 4 plus 2 pi. That's the same thing as 360. But in order to add these two, I have to have a common denominator. So what's 2 with a denominator? We would convert this to what? 8 pi over 4. That's the same thing as 2 pi, isn't it? Now I can add them. That equals 13 pi over 4, so that is coterminal with that. And then I can subtract 2 pi to get the other one, which is 8 pi over 4. And that would give me negative 3 pi over 4. So these three angles share the same terminal side. Make sense? Okay. All right, radian. We've already discovered and talked about what a radian is, but I'll just write it down here. It's just an angle measure in terms of pi. In trigonometry. Two pi equals 1 rotation. Does anybody remember what the degree measure was of 1 radian that I showed you yesterday? Do you remember? It was about 57 degrees, yeah. 1 radian is approximately 57 degrees. All right? Converting. So another thing you're going to have to practice is converting between degrees and radians. It's really easy, really super easy. Here's the formulas you use. And one thing I want you to be aware of is this is not multiply. It's just a unit notation. So pi radians. It's just unit notation. Same with here. So basically, if you have degrees and you want to go to radians, you've got to eliminate the degrees, so you would multiply by this. So 75 degrees times pi over 180. And when you do that, you end up with whatever 75 over 180 is reduced, which is 5 pi over 12. So that's the radian measure. Does anybody picture where that would be on the unit circle? About? I would look at it like maybe like this. 6 pi over 12, which is pi over 2, correct? Do you know where that is? 90 degrees, right? So this would be a little bit to the smaller than 90 degrees. Make sense? If you think of it that way. Okay. All right, so this one here, we've got to convert radians to degrees. So that means I got to get rid of the pi. So I'm going to multiply it by 180 over pi. That'll cancel out pi. And that'll leave me with degree measure. So that cancels out pi. And you're just multiplying negative 5 times 180 divided by 4. Multiplying fractions, right? Okay. That gives me negative 225 degrees. Negative 5 times 180 divided by 4. Okay, 145 to radians, so I need to go to radians, which means I'm going to get rid of degrees by putting degrees in the denominator. Again, that would just be 145 over 180 reduced with pi in your answer. Do you know how to reduce fractions on the calculator? I'm assuming you do at this point. Using the math button does it for you. If not, ask me and I'll show you. Okay, let's get rid of radians here. 3 pi over 2, which means I need to have pi in the denominator and degrees in the numerator so that my pi's cancel. 3 times 180 divided by 2 is 270 degrees. Doable? Yeah. It's not too bad. Okay, a little bit more and then we're done. Hey, this I just taught in geometry. So I was kind of excited. I'm like, oh, I just taught that. All right, sector. Maybe you remember, maybe you don't. A sector is a region or part of a circle, like a piece of apple pie. Apple's the best pie, so anyway. It's a region or part of a circle bounded by 2 radii and an arc of the circle. Basically, it's just a piece of pie if you were to cut out a piece of pie. That's what it is. It's a sector. Yes. Pardon the pun, right? Okay. Central angle is an angle. Maybe you remember this, maybe you don't. An angle with its vertex at the center of the circle. Okay. Although, when I looked at these formulas, I'm like, that's not how I taught them how to do it. But, for curious minds, do you remember how to find the sector? How they taught you last year? Or the length? Does anybody remember? It was a proportion, is how they set it up. Do you remember that? Okay. It wasn't bad. It's like if you do arc length, or I'll call it S, you do it over the circumference, equals theta over 360. This is how you learned how to do it. Arc length over circumference equals theta over 360. Well, I thought, how did they get that to that? But it works. Do you want to see? Because I know you do, because I know you're curious. Okay, watch. If you cross multiply here, look what happens. 2 pi r times theta equals 360 times s. If I divide by 360, what cancels out here? 2 pi is 360, isn't it? Look at that. That was my exciting morning. I'm like, oh, that's cool. That works. So that's where that comes from. Okay? And then area, it's the same thing. You could do the same thing. It was a proportion that you learned last year. You could simplify it to that. So we're just going to work with these. Children at a day camp are playing a game on a circular field. The shaded sector in the figure is called the safe zone and is marked off by rope along its outer edge. I'm going to put a star by this because I sort of remember this might have shown up again somewhere. Kind of the same sort of problem. All right? Find the length of the rope and the area of the safe zone. So we're going to do the length of the rope first. Okay? First I'm going to do it in regular feet, and then we're going to represent it in radians. So we'll do it both ways because you might see both ways. So if I use this right here, the length of the rope is the arc length here that I'm working with. So S equals my radius, which is 18, times my central angle. And when I do that math, I get 2,160 feet. It's a pretty big area. However, we should do it in radians too, just because. If I do it in radians, I have to convert that central angle to radians. And that's pretty easy. We just learned how to do that. 120 degrees times pi over 180. I'm doing the central angle right now. Equals 2 pi over 3 radians. So then I just use the same formula, except I'm doing it in radians for the length of the rope. So it equals the radius times the central angle in radians. That would just be 12 pi feet. So you might have to do it either way. So now let's do the sector. Okay, so we're going to use the other formula now. Area equals 1/2 times the radius squared times the central angle, which is 120 degrees. And when you do that, you get, that doesn't seem to make sense. I wrote down 440 feet squared. Can somebody check that math? 60 times 18 squared? I don't trust myself on that one. Oh, I think it's 19,440. Is that what it is? I didn't read my writing properly. Sorry, that's kind of a mess there. 19,440. And then you could also do it in radians if you have to. You just use radians for the central angle. And when you simplify all of that, look at this, look at this, look at this. Before you jump in and do all this math, here's 1/2, here's 2 in the numerator. Those would cancel out, wouldn't they? Makes your multiplication a little bit easier. Do you have to? No. But so then it's just 18 squared divided by 3, which would be 108 pi feet. Okay? Wasn't that fun? It's not that hard because it's some stuff you've done last year. So that's it. It was kind of long, I know, sorry.